The project involves integrating Sentry error monitoring with Winston Logging specifically for Node.js processes. It includes a working demo that was tested prior to its deployment for monitoring within Post2Video's BullMQ workers. The motivation behind the project stems from two challenges faced when following Post2Video's Next.js Sentry setup: the need for Sentry setup in BullMQ workers across different Node.js processes, and the desire for a seamless integration of Winston for logging to ensure proper error reporting. Key takeaways include the importance of a manual wrapper for error logging to ensure raw error objects are sent to Sentry, the necessity of Sentry's global handlers for catching unhandled exceptions, the crucial configuration of Winston to prevent missing stack traces, and ensuring Sentry is imported first in the application setup to properly register error handlers. Installation requires following 6 straightforward steps to add Sentry error monitoring alongside Winston Logging successfully within the Node.js project. The first installation step involves installing dependencies using the command pnpmi to ensure all necessary packages are included in the project. For the second step, environment variables must be set up by creating a .env.local file, including the essential Sentry DSN variable that specifies where Sentry should send error alerts, which can be obtained from the Sentry project settings. In step 3, the Sentry monitoring must be initialized by creating a srSentry.ts file, where you will set up the Sentry configuration to handle error reporting. The fourth step involves configuring the Winston Logger by creating sslogger.ts file, ensuring it is set up to effectively log error messages and integrate smoothly with Sentry. Step 5 requires using the Sentry Logger setup in your application, which will involve creating the src index.ts entry file to incorporate logging mechanisms into the main application flow. The final installation step is to add relevant scripts to the package.json file for building and running the application, ensuring a seamless start and development process. To test the integration, executing pnpm dev should trigger alerts in the Sentry dashboard and send notifications to your email. For production configurations, it is recommended to ensure Sentry runs only in production environments to conserve your event quota, which can be done by wrapping the Sentry initialization in an environment check. The technologies utilized in this project encompass a diverse stack aimed at optimizing error monitoring and logging. The core stack features Node.js as the worker process alongside TypeScript for added type safety and development efficiency. Post2Video employs BullMQ for robust background job processing, essential for handling asynchronous task management. Monitoring and observability in the stack are primarily covered by Sentry for real-time error tracking and alerting, complemented by Winston, which serves for structured application logging. The code structure includes key files whose configurations and functions form the backbone of integrating Sentry monitoring with Winston Logging. In Sentry.ts, Sentry is initialized by importing it from the Sentry node package, configuring it with the DSN for error reporting, and establishing a sample rate. This is essential for adapting to production settings by altering the sample rate accordingly. The Logger.ts defines the Winston Logger with specific settings such as error level, output format, and how errors will be logged. It ensures stack traces are included when logging errors by employing the proper format settings. The export statement for the logger is crucial, allowing it to be used across your application for consistent error logging. Index.ts serves as the application's entry point, featuring an interactive menu that provides options to log a test error or throw an unhandled exception, demonstrating the integration of the Sentry error reporting system. In the context of error handling, test errors are logged via log error, and if an exception is thrown, it is caught and logged, showing Sentry's real-time error reporting abilities. After logging errors, the function provides feedback, confirming the logged errors are visible in both the Sentry dashboard and via email notifications. Utils.ts introduces a central utility for error logging, which facilitates consistent error reporting by capturing both custom and standard error objects, logging them through Winston, and sending them to Sentry. A demo is provided demonstrating how to invoke the Sentry error reporting system, illustrated with a screenshot of the DSN location in the project settings. An image of the terminal displays the command pnpm dev, showcasing the available menu options to test error logging and Sentry alerts. Upon entering option 1 in the interactive menu, a logged error results in an email alert being sent, which is shown in the Sentry dashboard as well. The Sentry dashboard provides a detailed view of the logged error issue, allowing access to the stack trace to identify precisely where the error originated within the code. The stack trace captured in Sentry highlights the exact line in the code that caused the error, offering critical insight for debugging. Entering option 2 triggers an unhandled exception, causing Sentry to send out an email alert for the uncaught error, alongside a corresponding notification in the dashboard. The Sentry dashboard reflects the unhandled exception issue immediately upon its occurrence, illustrating the effectiveness of real-time error tracking. Similar to logged errors, the stack trace for unhandled exceptions is also displayed within Sentry, aiding developers in pinpointing the source of errors. The section on points of interest discusses valuable lessons learned and notable decisions made during the integration process. The decision to avoid using Winston Transport Sentry node arose from its failure in production due to its inability to process serialized error objects as actual error instances. Instead, custom logging using Sentry.CaptureException was adopted for more reliable error handling. The difference between Sentry's capture exception and capture message methods is highlighted, emphasizing that capture exception should always be used for actual error objects due to its ability to include stack traces and trigger alerts. The log error function is designed to handle TypeScript's unknown type for errors, allowing it to convert non-error objects into proper error instances while maintaining streamlined error capture for improved clarity and debugging. References provide external resources and documentation links on Sentry usage within Node.js, facilitating further learning and integration guidance.